Hi, good afternoon, everyone. Thank you for joining us today. I'm Angela from Servo Dynamics. It's a pleasure to have you here today at our webinar. So once again, good afternoon to you. So we are just waiting for a couple more to come in to our webinar before we start off the show. So maybe give us 1 minute or so while we wait for more people to come in. Okay, now we will start our webinar official. So good afternoon again to everyone. Thank you for joining us today. I'm Angela from Servo Dynamics, and it's a pleasure to have you here today with us at our webinar, Industrial Standards for Robotic Safety. So before we start, allow me to go through some house rules with you. Please be informed that we'll be doing recording for this webinar, and if you have any questions, you can actually type your questions into the chat window, and our speakers will address your questions during the Q&A segment after all the speakers have presented. So we'll kickstart today's session with an introduction to Cobot Safety, and then followed by standards and specifications related to collaborative applications. And lastly, we'll be touching on the usage of robotics and AGV. Today, we are very honored to have with us 3 speakers. So we have Mr. X from Universal Robots, and we have Mr. Niels from OnRobot, and Mr. Mark from Pilz. So without further ado, I shall hand over the mic to Mr. X to kickstart today's session. Over to you now, Mr. X. Mr. X, I think we can't hear you. You might have muted your mic.
Can you hear me now?
Yes, I can.
Good.
Thank you.
Good afternoon, everyone. I think as of today, we talk about a lot of our own safeties because of COVID-19. But today, let's share a little bit of something that's very different on collaborative robot safety. So today, I'm going to share with you on introductions to Cobot Safety. Today, beside myself, I also have another colleague, Andrew, will be presenting on terms of the UR safety configurations in our systems. So let me do a quick introduction about UR. We are a Danish company headquarters in Odense, Denmark. We have 29 offices around the world, as you can see. We have 690 or plus employees. The number keeps changing, or we have close to 700 today. I think by far today, right, Universal Robots is one of the single largest collaborative robots manufacturers or technology providers that just focus on cobots manufacturing and technology deployment. As of today, we have deployed more than 44,000 robots to the market, and Universal Robots remains a pioneer as well as market leaders of collaborative robots. We have more than 50% market share that is deployed in the market. Beside the collaborative robots, we also work very closely with UR Plus partners, and we have introduced a UR Plus platform that we have a third-party system solutions that are able to integrate very well with Universal Robots. So we have more than 200 over Universal Robots Plus products that is in the UR Plus platform. So in terms of the product lines we have the CB3 series product line, and recently we have also launched a new flagship product called E series product line. From UR3, which is a 3 kg payload robots, and all the way up to a 16 kg payload robots we have. Beside that, we also have a OEM DC version and an AC version. that is available for OEM makers. Example like AGVs that they would like to integrate UR robots. They can actually use the DC versions to actually put it together with its smaller and more compact sizes. And it's DC that they can draw power directly from an AGV. All right. So I'll hand over to my colleagues Andrew to share with you on the collaborative robot safety.
The entire Universal Robot Safety System has been certified by TÜV Nord in accordance with ISO 13849-1 2008 to comply with Performance Level D. So you can go and look at that standard for more information about what that means, but basically it gives an assurance of the reliability of all of the safety functions here, that they have a very, very small probability of dangerous failure. That TÜV Nord certificate is available for download on our website, and it's a multi-page document that also includes some information on the conditions under which the tests were carried out, and also the safety functions that were tested. And that's what I've pulled out on this page here. You may have heard in our marketing materials that our CB3 robots have 15 advanced safety functions, of which 7 are fixed and 8 are adjustable. So just to clarify that here, I've pulled out that list of safety functions and highlighted the fixed ones in red. So those are the emergency stop and safeguard stop, and then all of the safety outputs. So those you can enable and disable the safety outputs, but their functionality is fixed, whereas the other limits that we have here can either be directly or indirectly adjusted inside the safety system. Before we go on to talk about the various types of safety stop that you can perform with the Universal Robot System, I'd like to clarify some definitions. So you may have heard the term safety categories thrown around, category 2, category 3. These generally refer to ISO 13849 and the overall reliability of a safety system. But here we're talking about stop categories, and these come from IEC 60204 or ISO 13850. And these talk about the various ways to safely bring a piece of machinery to a stop. So here we discuss safety categories 0, 1 and 2. Category 0 is essentially the same as just pulling the plug. It cuts power to the robot joints immediately and they come to an uncontrolled stop. Category 1 is where the robot is stopped with power, so brought to a controlled stop, and then once the stop is achieved, the power is removed from the joints. Then category 2 is initially the same. The robot is brought to a controlled stop, but the power is not cut. So this is where the joints remain powered, but they are monitored to ensure that the robot does not move while it's under this stop category. The first connector inside the robot controller, the yellow one on the far left with the red text, is our fixed safety inputs. It has emergency stop and safeguard stop. Both of them are dual channel signals, so they are redundant safety signals. The main difference between these two is that the emergency stop is a category 1 stop, which will fully power off the robot once it comes to a stop. This should only really be used in emergencies because it takes quite a long time to reinitialize the robot after this, or at least longer than the safeguard stop. The safeguard stop is the one that you should use if you're expecting this to happen every cycle or at least very regularly. So if a sensor is stopping the robot, not an unexpected situation. Now there are a couple of different ways to trigger an emergency stop in the UR system, and also 2 different types of emergency stop. So if you press the red button on the teach pendant, or you trigger the fixed e-stop inputs that we've shown on the screen here, this will trigger a robot emergency stop. And if you have one of your configurable outputs set to an emergency stop output, that will also be triggered. Most of the time when you're just stopping the robot system, that's okay. But if you are using that emergency stop output to interface with the emergency stop circuit on another machine, it is better to use a system emergency stop, and you can trigger that by configuring a pair of the configurable safety inputs to trigger a system emergency stop, and that does not trigger the emergency stop output, and that will prevent you from getting into a kind of deadlock situation where both machines are e-stopping each other and it's impossible to get out of that loop. And then the safeguard stop, as we mentioned previously, should not be used in emergencies, but in fact in scenarios where you're expecting it to happen fairly regularly. So this could be triggered by a sensor that detects the opening of a machine door or the door to a work cell. It could be a light curtain being triggered, or it could be an output from a safety scanner that has detected someone entering the workspace of the robot. So you can reset this safeguard stop either using one of the configurable safety input pairs, or if you don't configure that, then the signal will reset itself automatically and resume the program when the signal goes back to its original state. In order to access the configurable part of the UR safety system, we first need to have a safety password configured. So we can do this in the Setup Robot and Set Password screen. Here you'll see that there are actually two passwords that we can set. So the system password can be used to block access to the programming part of the software and also the settings, but there is an additional layer of security to access the safety settings. So this password here would be known to the person doing the robot risk assessment, so the operators on the line would not be able to come in and adjust the safety configuration of the system. Once this has been set, we can go back out to the main menu, go into Program Robots. Under the Installation tab, we'll find the Safety menu, and at the bottom here we can insert our safety password, press Unlock, and this will give us access to adjust the configuration of the UR safety system. Once we enter the safety configuration screen, the first thing that we see is the General Limits tab, and this is our basic view of our general limits, and this just gives us one slider that allows us to adjust the values for the maximum force, power, speed and momentum that the robot is allowed to apply to its environment all together. So this goes from very restricted, which would be a situation maybe where there's a particularly hazardous tool on the end of the robot and we really want to limit the force and speed that it can work with, through restricted, and then we have the default settings here, and then least restricted is a configuration that we really only want to use when the robot is well away from people. Now these four sets of limits here, you may be happy with just configuring them all together with this slider, but a lot of the time you will want to go into the advanced settings by clicking the button in the bottom right here and actually make adjustments to the individual values based on your risk assessment. Now these four values can be used together. Different countries and different companies may have their own guidelines for whether you should be limiting the TCP force, the mechanical power of the robot, the TCP speed, or indeed the momentum. So the momentum also takes into account kilograms here, so that's the payload. So here you will be able to move the robot faster with no payload than if you were carrying maximum payload. On this advanced settings screen, we can see that there are actually two columns of values for each of these safety limits that we have. One of them titled normal mode, the other reduce mode. So what this means is that we can actually save two sets of configuration into the safety controller and allow the robot to switch into a more conservative reduced safety mode when certain conditions are met. So at the moment you'll see that these values for reduced mode are grayed out and we can't actually make changes, and that's because we haven't configured that condition to trigger the reduced mode. This can be done either when the robot moves into a certain area of its workspace or when it receives a trigger from an external safety device. And we'll look at how to configure those in a bit more detail in a minute. The next tab is Joint Limits, and here we can configure the maximum rotational speed or the position range for each individual joint. So here again we have one set of values for normal mode and one for reduced mode. We have a TCP speed limit under the General Limits tab, which is defined in millimeters per second. Here we can define the angular rotational speed of each joint in degrees per second. So here we might want to limit the speed of rotation of the base or the shoulder joint, because a high-speed rotation of each one of those joints would provide a very rapid movement of the tool. Under the position range, we have a minimum and a maximum value for each joint. Now the default for almost every joint is minus 360 degrees to plus 360 degrees, so that's 2 full turns of each joint, other than the UR3 tool, which can spin infinitely. We may want to restrict these values if we know that the robot is only going to be working in one small part of its workspace. We may want to cap the rotations on each one of the joints to make sure it doesn't go outside of that range. If it did, maybe it would collide with other equipment, an operator, or even with itself. And so by setting those limits in here as opposed to in the program, we then have a safety rated kind of fail-safe. We know that the robot will not be allowed to go outside of those limits regardless of what the user does in their program. The third tab under the safety configuration menu is the boundaries tab, and this allows me to configure up to 8 safety planes around the robot's workspace that restrict under what conditions the robot is allowed to enter that part of the workspace. We also have an option here for tool boundary that I'll cover on the next slide. So in order to configure these safety boundaries, I need to first create a feature outside of the safety menu, and then I can copy that feature and use it as a safety plane in my safety configuration here. There's a very good guide on how to do this in the 6th module of UR Academy, which is all about safety configuration. So once I've chosen my feature here, I see it appear on the screen in the robot's workspace, and then I can choose to offset it if I want to. So let's say if I offset it by 100 millimeters, we'll see it shift slightly away from the robot. And then I have this boundary restricts drop down box here, and this defines what the functionality of that plane actually is. So we have 5 different options for our boundary mode that we can select in that drop-down list. And the first one, disabled, is fairly self-explanatory. If it's disabled, it doesn't affect the movement of the robot at all. The other 4, we're going to use our simulated environment from the last webinar to have a look at how those work. So the normal option means that when the robot is in reduced mode, as we can see here, it moving slowly, it is not affected by that boundary at all. So the boundary is disabled and it can pass straight through it. But as soon as the robot switches into normal mode and starts moving at a higher speed, we see the boundary changes color here, becomes active, and then blocks the robot TCP from passing through it. So reduced mode does the opposite of this. When the robot is in normal mode and moving at full speed, it can pass through that boundary, but as soon as it switches into reduced mode, the boundary becomes active and it will block the robot TCP from passing through it. The third option, both, is a combination of the previous 2. So this means that it is active in both normal and reduced mode, and regardless which one the robot is in, it can never pass through that boundary. The last option, trigger reduce mode, is quite different to the previous three in that this one will actively change the safety mode of the robot. So when the TCP is on one side, we can see the boundary is green and the robot is in normal mode, but when it passes through it, the boundary turns blue and switches the robot into reduce mode. Now this is useful in a situation where you want the robot on one side of the workspace where you know that people cannot enter working at as fast as possible, but then when it moves into the collaborative part of the workspace, it will slow down and complete that part of the task in a reduced mode. So while the safety planes restrict the position of the robot tool, the tool boundary actually restricts the angle of the tool. So just like with the safety plane, I do need to copy a feature in order to create this type of boundary, and the one I've copied here is the current position of the robot, so the tool is pointing downwards, and here I have a deviation angle. So at the moment it's set at 30 degrees, and so that means that the robot's Z direction is not allowed to deviate by more than 30 degrees from this direction. So if I can make that a little bit bigger, you can see that the cone becomes a little wider, and we can again configure whether this is in effect in normal mode, in reduced mode, or in both of those. This one we can't actually trigger the reduced mode, but the reason that you might want to do this is if you have some sort of potentially harmful tool on the end of the robot. Let's say it could be a spray painting gun or some sort of dispenser, and you know that your workpiece is on one side of the robot and you only want the robot tool to be able to point towards that workpiece, so you can restrict the angle of the tool, and so the robot can still move all over its workspace, but it has to still point in this one direction. The final tab under the safety configuration is the safety I/O. So all of the yellow connectors, apart from the fixed safety signals with the emergency stop and the safeguard stop that we've already mentioned, all of the others with the black text on them are what we can call configurable I/O. So we can either use them as standard digital inputs and outputs and control and read them individually, or we can pass over control of them in pairs to the safety system, and they then acquire a safety rated functionality. So you'll see here that all of these signals are in pairs, 0 and 1, 2 and 3, 4 and 5, 6 and 7. So this is because it's a redundant configuration. We have 2 wires for each function, and by default this is the configuration. So the only signal that is assigned by default is the safeguard reset on input 0 and 1. So we talked about this briefly when we looked at the safeguard stop earlier. If we don't have a safeguard reset configured, the safeguard stop is automatically reset.
Thank you, Andrew. So thanks for joining us on the webinars. We do have upcoming webinars here as well. If you're interested, feel free to actually drop an email into urSCA@universal-robots.com, and I will be able to send you the registration link. Angela, I'll hand it back to you.
Thank you very much, Mr. X. So that was a great presentation. So we'll now move on to our next topic, standards and specification related to collaborative applications. I shall now pass the mic over to Mr. Niels. Mr. Niels, thank you.
Thank you, Angela, and thank you to Servo Dynamics as well for organizing this and for everybody attending today. So my name is Niels. I'm from the company OnRobot. And basically what I'll be talking a little bit about today, of course, is the whole safety issue, but I'll starting a little bit talking about who OnRobot is, what kind of products we are selling, and also how this relates to safety when we talk about collaborative applications. Now, I do mention customer success story here, but I think we are a little bit behind schedule, so I'll probably skip that today. So who is OnRobot? So similar to OnRobot is a Danish company. We are based in the same city as about 9 kilometers away. But basically what we are focused on is the end-of-arm tools, or end effectors as it's also called. And we are focusing on the collaborative market. So OnRobot itself, we are about 5.5 years old, still sort of considered a startup, but basically we are a mix of 5 different companies, 3 companies from Denmark, 1 from Hungary, and 1 from US, that are merged into one larger company focusing on collaborative end effectors. So the size of the company right now, we are roughly 185 employees, similar to you are. We are growing very fast, and these numbers change almost from week to week. We have our R&D and manufacturing capabilities in 3 countries, which is Denmark, Hungary, and the US, and multiple sales offices. When it comes to the APAC region, I'm based out of Singapore, so OnRobot Singapore is the regional HQ for APAC, but we also have offices in Shanghai, in Anyang, just outside Seoul in Korea, and in Tokyo in Japan. So if any of you have businesses up there in that side of North Asia, we can also support you there. What is the vision of OnRobot? So basically what we are trying to build right now is what we call a one-stop shop for collaborative end effectors. So what does this mean? It means we want to be able to integrate our products with every single robot brand out there. It doesn't matter whether it's a Cobot or light industrial robot. We are already partly there in that part of the business. We want to be able to cater products to all kind of applications, whatever applications you have and you need. We want to be able to have a tool for that, which means ultimately we need all accessory types. And ultimately we want to be able to operate in all industries. And because we are only selling electrical products, we can already now work in all industries. So we have sold to banks as an example, where you don't want to have pneumatics products. What are our product range? You'll basically see here, as you can see, majority of our products right now are basic grippers. As I said, they're all electrical. So we have a different range of both suction grippers or vacuum grippers, 2-finger gripper, 3-finger gripper, and a few other technologies, including food safety soft grippers. We also have force torque sensors. We have one of the only 2.5D vision systems in the market. We recently launched our collaborative screwdriver, and we also had quick changes or tool changes, that they're also called in the market. Now to talk about safety in the collaborative workspace, I'm sort of going to do that in sort of 2 areas. One is, how does the OnRobot products fit into this area? How do we help keeping applications safe? And the other part of it is talking about collaborative applications, right? So talking a little bit about what is collaborative, in case you're not aware. I mean, there's 2, depending on who you ask, but generally there's 2 key things here when you talk about collaborative. One is safety and one is being easy, right? So safety is safe to work around humans and safe operations, which is something industrial robots can't do. And the other part is in terms of easiness, in terms of setting it up, moving it around, deploying it, programming it, and basically not needing a big engineering department to be able to set up and run a collaborative robot or collaborative application. Now I mentioned pre-COVID, so I put something for post-COVID because as X also mentioned to start with, the world has changed a little bit and we are now going into a new normal, where I think also the whole collaborative application setup is very, very important. So what is the additional benefits for manufacturers, or it could even be cafes and restaurants and so on, when it comes to collaborative applications? Basically is that you want to make sure you have social distancing, keep your staff health and safe. That is very, very important. And you also want to have health and safety in products, so you don't want people touching your products. It could be food products, it could be other products that are moved from one person to another. And having collaborative applications take over some of these applications rather than humans doing it, for sure will assist here. Another thing I just put on in terms of easiness is when we talk about onshoring and reshoring. I mean, we talk about Singapore, for instance, maybe being able to bring some of the businesses away that you have lost over the years because of high cost. When you have automation, and especially with collaborative robots and collaborative applications, you have low cost or a lot of benefits to use collaborative applications. So that gives you an option to be able to reshore maybe some of the businesses and technologies or businesses you lost over the years. So that's another way, and it's very easy to do with collaborative robots rather than using industrial robots. So what is safety in collaborative applications? So generally, we're talking about collaborative applications. We're talking about cobots or collaborative applications working near or with humans. So that's basically the big part of it, you know. And you can easily adapt to changing needs in a production. And this is particularly important when you talk about SMEs. You know, they had typically high mix, low volume. They change from week to week or month to month, different products and different setups and so on. So that is very, very important. So basically, when you talk about collaborative applications in general, one thing you get, I was thinking in this region, and especially in Singapore, you get a lot of benefits in terms of increase your productivity. You can automate repetitive tasks, and therefore you enable manufacturers to reap the benefits of say, high returns on investment, not necessarily fast return on investment, but definitely high return on investment. So what are the different kind of safety standards? And I know in the UR presentation, you already briefly mentioned, but what are some of the safety standards that you have to be aware of here, right? So one thing is we talk about the collaborative workspace, and what is that? There's two ISO standards, or one ISO standards, one technical specification that talks about what is the collaborative workspace. The ISO 10218 says that the space within the safeguarded area where the robot and human perform a task simultaneously during production operations. And the description is sort of similar for TS 15066. So basically the area wherein the robot, the gripper, any other tools you're using plus the human, the area they're working within is the collaborative workspace. And of course, when you talk about collaborative applications, it's always important that you look at the whole setup, not just the robot, not just the gripper. There's no point just having a collaborative robot and think you have a collaborative application. It doesn't work like that. You need to do a proper risk assessment and look at the whole setup to have a collaborative operation. But basically, I'll talk about that a bit later as well. So what are some of the standards and specifications? One is ISO 10218, which talk about the robot and robot devices. So it just talks about the robot itself, but no other equipment or devices as part of it. This is part 1 of 10218. The second part is part 2, which basically talks about the robot as well as the the whole system and the integration of say grippers and other types of end effectors or the robot cell, for instance. So that is ISO 10128, and these are ISO standards. So these are mandatory standards to follow. Now, ISO also have a technical specification, which is the 15066. So meaning technical specification basically means it's not mandatory, it's recommended, but basically what it does is it gives you certain requirements in what does it mean to have a collaborative application. And some of the things they're talking about here is having transient and quasi-static touch or contact with humans. So quasi-static is important for us because we are doing grippers and we're talking about clamping and how much pressure you can put on to have a safe application. So how does the OnRobot tools work with these safety features or safety standards? So one is safe gripping force range. So if you look at the on the left here, you look at this is from ISO TS 1566. It says maximum permissible force is 140 Newton. So basically what it says, and if you have a gripper that presses with more than 140 Newton, it is no longer collaborative. So you cannot call your applications collaborative, even if you have a collaborative robot. Yeah, that means you need to fence it off because it's not considered safe. For OnRobot, all our grippers are below 140 Newton, except our 3-finger gripper, which goes up to 250 Newton. But nonetheless, we still have certain safety features in there to minimize the risk as this as well to comply with ISO TS 15066. Another thing we have is we have safety guards and safety switches. So basically, for instance, our 2-finger grippers, we have safety guards. That means you cannot put your finger inside the gripper and get it squeezed inside, which I guarantee will not feel very collaborative. We also have on our 2 RG grippers, we have safety buttons, which are PLD Crat 3 certified, which basically means that if you get your finger inside and it touches any of the buttons, the gripper will automatically stop from pushing anymore, so you'll keep your workers safe. We also have certain safety capabilities with our products. For instance, one is we have our OnRobot force torque sensor, where we have something called FT Guard, and this only works on UR. So it's a software feature we have where basically you can set a certain force limit. So if you have the robot arm, the force torque sensor, and you have, it could be anything, polishing tool or something else that moves around. If it hits that tool, not just the robot arm or the elbow, but it hits the tool as well, and it goes above a certain force, it will automatically stop as well. So it's basically an added safety feature as well. In terms of our grippers, so one of the issues you sometimes see with non-collaborative or even some specific collaborative products out there in the market is that if you lose power suddenly, the gripper will open, and if you have something heavy you're carrying around, it might drop and hit something on the head or on the foot or whatever. Our grippers do not do that. They keep the grippers closed even if you lose power. So again, that's an added safety feature we have. We also have our collaborative screwdriver, which, for instance, when you pick up the screw, so most screwdrivers now, they will have the screw sticking outside, so it moves around. It's a very sharp item that could potentially cut somebody. What ours does is it takes the screw and it drags it inside, so when you move around, it doesn't cut anyone. It will only come out again just before it hits, it touches the object where it needs to screw in. And we also have a safety override shank in the shank in terms of collision as well, which is basically anything more than 40 Newton, which is not that high, it will also stop. As well as in general in status, we have an LED light along the screwdriver itself. It basically indicate if there's anything wrong with the screwdriver. And of course, in terms of design, I've just shown a few of the products here, but you will see all the products are very round. There's no sharp edges and so on. So this is also very important. So in case, again, it touches anybody, it touches a worker working together with the Cobot, for instance, it will not cut anyone, it will not scratch anyone. And again, this is part of the ISO GS 15066. Okay, I'll try to go a little bit faster because we are a little bit behind our time. So some of the things or some of the mistakes that is common for, let's say, manufacturers to make when they set up or when they include collaborative robots or collaborative applications is that they think just because you buy a collaborative robot, then you have a safe application. No, you do not. You can have a collaborative robot plus a collaborative gripper, and you might still not have a safe application, right? If you're carrying around your pick and place of a sharp knife, is it collaborative? No, it's not. So it's very important you do a safety, you do a probably safety brief of everything and look at all parts of the application that you're doing to see if everything is safe. Not doing a proper risk assessment, of course, is very important as well. You can't just say, oh, I've done 1 or 2 safety judges here and that's enough. You need basically need to look at everything that could potentially go wrong. It could be, as I said before, it could be dropping something, for instance. Or simplifying the risk assessment. Again, you need to go into details. Yeah, it's not just filling out a 10-point form and say, okay, this done this and this is done. It works. Everything is safe. No, you need to do it properly. Another thing is you cannot just consider risk from one activity. You have to look at all the different activities you're doing and all the activities that is happening around the collaborative area as well. Yeah, so you need to consider all the risk. It could be the robot is performing several movements and several types of different kind of things within the same application. So look at all the different areas, what the robot is doing and what the gripper is doing and what the end effectors are doing. Okay, I'll go a little bit faster here because I think we are we are going over time. Another few things I think that is just important here to talk about is make sure when you do a risk assessment that you involve everybody who's involved. This is people designing the setup. This is people implementing it. This is the workers that are operating there. Make sure everybody's involved in the risk assessment so you get the input for everybody. Another thing is you need to keep the risk assessment up to date. Yeah, you might. One of the things that are very important or very good with collaborative applications or collaborative robots is that you can easily redeployment. So today you do pick and place, tomorrow you do assembly, the day after you might do, I don't know, polishing, for instance. So each of these have different risk assessments. So if you move from one area to another, if you change the gripper from one type of gripper to another gripper, if you change from picking up a glass item to a metal item, for instance, there's different risks involved. So make sure you always keep up different part of the risk assessment is always up to date. Here's a few different kind of the most common applications in the industry using collaborative applications. I'm just going to mention the first one, which is machine tending as an example. So machine tending is very, very common for collaborative applications or for using collaborative robots at least. But it's still a very high safety concern. So to have a collaborative application is not enough, as I said, just to have a collaborative robot. You also need a collaborative gripper. But the other thing is you also need, as I said before, you need to look at what is it you're picking up from the machine you're picking up items from. Is it hot? Is it sharp? Where do you put it? Does it pass by humans? Is there humans involved in the operation? You need to look at this as well. So last slide, which is kind of summarizing what I said already. So basically, as I said, there's really no point in, if you're talking about collaborative applications, there's no point in just looking at the collaborative robot and think, okay, I bought a collaborative robot, now I have a collaborative application. No. Or if you buy a collaborative gripper and you put it on any robot out there and you think, okay, I have a collaborative gripper, now my application is collaborative. No, it's not. You need, as I said, you need to do a proper safety assessment. You need to look at everything, all the tools you're having, what you're picking and placing and so on, to make sure you understand whether you have a collaborative application or not. So look at the whole application, not just one part or a few parts of it. That's very, very important. So a little bit rust, but again, if you have questions to it, you can ask it afterwards. I'll answer as much as I can, or you can talk to Servo Dynamics afterwards if you need brochures about our products or more information. So that's it from my side, and I will leave it for Angela now. Thank you, Angela.
Thank you, Niels. That was really a great presentation. So we will have our Q&A session at the end of the presentation. So now we'll move on to talking about the usage of robotics and AGV that will be covered by Mr. Mark. So over to you now, Mr. Mark. Thank you.
Thank you, Angela. Thank you everyone to join this webinar. So my topic is about HRC, and okay, I put a little bit extension on AGV because this is also somehow relevant with the robot automation. So I'm talking about the path to safety, right? Just now we have heard from you, Andrew, from OnRobot Niels, a lot about safety. I think they have done a very good explanation of many safety concepts and do's and don'ts. I think it make my job easier. Of course, also left less time for me. So why I call it HRC? I don't call it Cobot application. HRC means human robot collaboration. So basically, yes, it's definitely related to Cobot, but I can put it this way: Cobot is built for HRC. It's built for human robot collaboration, but HRC can be also achieved by other robots as long as some conditions are met. Right. So we will go through this in a little bit more details. Sorry, next slide. So just now, I think all of them mentioned this standard ISO 10218, and I think Niels also mentioned -1 and -2. So I'm not talking about -1 because -1 is only relevant to robot manufacturer. right? It's talking about the robot standard, right? The standard for robot. But -2 is about robot system, the whole system. And the TS, the technical specification 15066, it's dedicated for collaborative robot application. So there are 4 modes defined in these 2 standards, right? These 2 standards actually work together. So mode 1, 2, 3, 4. So 1 and 2, the upper 2, safety, related stop, hand guiding. So basically, actually there is no collision, right? So actually the human and robot, they may exist in the same space, but either one is moving, the other one is not moving. And the third one will be more interesting now. The third one is called speed and separation monitoring. So this one is actually, the system is monitoring the position and speed of the robot, but it still makes sure that the operator do not collide with the robot. So this is still not Cobot application, but close to Cobot. And then the third one, mode 4 is called power and force limitation. Just now you also heard from Andrew about how to set up the power and force limit in the the safety software, right? So this is talking about the force limiting. And with this mode 4, it allows, the standard allows the robot and the human coexist in the same space, and they allow the collision, right? But with some conditions. The condition is defined in 15066, and I think they also mentioned about the force and pressure, right? These are the limit, the threshold, the standard defined that under this kind of limit, right? Within this limit, this collision is allowed, right? So we will go a bit more details on that. And also I put here, but maybe I'll not go into the details because of the time constraint, the AGV. AGV, there is also the standard right now. The standard is called 3691-4, and the standard is called industrial driverless industrial truck, right? So it's not called, actually not called AGV. AGV, it's a truck. So it's talking about industrial AGV. Okay, so the path to safety. So there are hurdles. So what are the hurdles? What we want to achieve? We want to achieve a safe machine, a safe robot application, right? So at the end, maybe we want to achieve CE conformance. I put a question mark because we are not in Europe, but we want to achieve a safe machine which is comparable with CE standard, right? And then there are hurdles in front. First, we have to do the risk assessment, right? I think just now Niels emphasized on this in many times. And the risk assessment, of course, the very important part is to identify the collision scenarios. With the HRC application, just now we said we allow the robot collide with human, right? So then this collision scenario must be defined, and the limit must be also find out. And then after that, we do the safety concept, we make the safety design, but very importantly, we also have to do the validation. We have to validate that our design is correct according to the risk assessment. So the first hurdle is risk assessment. Okay, I think I'm not going to go into too much details. The robotic standard 10218-2, again, so emphasize this is for the robot system. I think most of the people here are related to this system. So this is relevant. And also there is a standard 12100. This is the generic risk assessment standard. You can take a look as a reference. Right, so this defined very well about how to do the risk assessment. And also very important when you do the risk assessment is that we have to look at intended use, right? The robot you want to do some kind of a pick and place, right? This is intended use, but we have also to look at reasonably foreseeable misuse. This is specifically true in HRC application because we allow operator to get very close, to get into the workspace of the cobot, then the chance of collision is very high, right? And then we have to look at different kind of scenario and tasks. I think Niels also just touched on that. So all the tasks, all the scenarios will have to look. For examples, the robot picks something and drop the parts. Then the operator may bend down to pick up the parts. And that at that time, the operator may collide, his head may collide with the robot joint, right? So here I show on the left, the second line, the left, this is showing this scenario. And the right is also similar. It can be a passerby, right? It may not be even the operator or the engineer. It can be the passerby, look around, right? You can imagine the exhibition kind of environment, and he cannot predict what robot next movement is. The robot may also hit his head, right? Even his, more dangerous, hit his eyes. So that kind of reasonably foreseeable misuse must be also identified and put into the risk assessment. Also, another very important point is risk assessment. When we do the risk assessment, we have to take all the safety functions out. So, for example, the Cobot, we have all the safety features, but when we do the risk assessment, we have to assume all the safety features are not there, right? So it's just a bare robot, and we look at the tasks and the operators maybe involved in this, and then do the risk assessment. And after that, with the risk assessment, then we do the safety concept. Safety concept first, we do the inherently safe design. I think the Cobot and the safety grippers, they all address this topic very well. So, and also when you design some other things, then you can, for example, design a very large surface, flexible surface, or even try to design the layout of your whole machine, just avoid collision, right? If you are able to avoid a collision, that's perfect, right? And then the second step, if all this is not possible or not enough, then we have to think about, putting the additional functional safety devices to make the system safe. We're putting sensors, we're putting control technologies, right? In this case, Pilz, we have a lot of product for that, right? Like curtain, and that scanners and radar. We'll quickly go through that again. And with this Cobot application, for example, I show the layout here, right? You're on the upper right, you have the Cobot workspace. The human may overlap with the robot workspace, but the other side, this is not a Cobot workplace. So the robot can work faster in the other side. Okay, maybe reduce the side on the space that they may collide with operators. All these are the functional safety design you can put into this safety concept. And then don't forget, the last is information for use, right? So some signboard, right? And also the PE, right? Especially for Cobot, I think the protective glasses can be very, very useful for that. And as I mentioned, after this is not finished, you have to do validation, right? Just now, I think Andrew also mentioned the performance level D of the robot. And so how to, whether your system achieves this performance level D or category 3, right, according to the standard, and whether your stop time, right, is according to the assessment and the design, you have to validate, you have to test out, right? And there is some software for to help you to calculate the performance level. And also for the HR application, this is special because of this collision, right? So the TS 15066 define the threshold. The threshold is actually how much pain a human can take. So then you have to validate. You have to use some instrument to test whether this Cobot, within this kind of scenario, whether it will create, more force or pressure than the threshold or than the limit that you define in the risk assessment. So we Pilz have this product called PRMS, which is able to help you to do this measurement and put it as a validation documentation. Right. So this is the whole safety life cycle: risk assessment, safety design, and validation. At the end, okay, you reach safe machine, maybe to the CE standard. So what Pilz can help? The Pilz is a German company. So right now I'm sitting in the German center. And we provide the safety components, safety sensors, safety control system, and also very importantly, we provide safety services. The safe control system, electronics, right, sensors, controllers, right, and IOs and so on, but all safety centric. And for example, light curtain, right, is very typically used in the robotic application, and we are the only one in the market who can provide a type 3 light curtain. Type 3 light curtain is performance level D. So most of the product on the market is either performance level C, which is type 2, or performance level E, which is type 4, either not enough for the robot application or too much. So performance level D is only one that we can provide in the market. And also laser scanner. So the laser scanner is also widely used to measure, for the space, and this can be used in both robotic application and AGV as well. When it's used in AGV, then we are also able to provide live navigation information for the navigation purpose. And also we launched a new product. This is the radar. It's a safety radar system, and the unique feature is that with the radar system, this is not very sensitive to, for example, particles, dust, or even raindrops, right, or sparks, the welding sparks, which laser scanner may have difficulty to deal with. So Pilz provided the safety service from risk assessment, so we can help you to do the risk assessment, to design the safety system, and also to do the validation, and even we can also help on the CE marking if you are making a machine for the European market. And last but not least, this is the training. So we provide training for our customers from introduction, very basic safety knowledge, and to the fundamental. In the fundamental, you can find there is the module for robotic safety, and in the advanced module, we have also the human-robot collaboration training as well. So there is also expert about safety machinery expert, which is TÜV certified, and we are going to launch the certified robotic safety expert maybe next year. So that's my last slide. So Pilz, we are a company that dealing with machinery safety. I think we are the only company in this region who can provide safety control systems, safety sensors, and safety provide the safety knowledges and services, as well as training, and all from one company, and we are dedicated in the safety business. So thank you very much.
Thank you very much, Mark. So we'll now move on to our question and answer session. So if you have questions, please enter them into the chat window and our speakers will address these questions. So do indicate on the question the company or the speaker you are directing this question to. Thank you very much. Okay, so we have a couple of questions coming in. So the first question that we have is, do Pilz provide risk assessment? So Mark, can you help to address this question?
Yes, as I mentioned, Pilz provide safety control systems, components, as well as service and training. So service is our business, and we provide the risk assessment to many different type of companies. For example, end users, they may also ask us to do the safe risk assessment, as well as machine maker and system integrators. Yes, we do. Sorry, Angela, you are muted, I think. I cannot hear you.
Oh, sorry. I muted myself. Okay, so the next question we have is directed at OnRobot. So, Mr. Niels, I believe you can help to address this question. What is the main difference between OnRobot grippers and pneumatic grippers?
Well, I mean, there are several. So I think if you look at, I mean, first of all, is the setup, right? Many of you might have installed pneumatic grippers before, and you are fully aware the time and the complexity it can take to set up a pneumatic system. You know, you need air supply, the compressors, you need the cabling, and so on. It can take sometimes days to install and set up. And of course, you also pay for the air, even though it's installed, you still pay for it. So, you know, every minute you use the gripper using air, there's a cost to you. What we do basically is that, and the second thing also is that unless you have your own engineering department, you basically need an SI to install this as well. For us, what we have with our collaborative electric grippers is basically that you can, if you have a robot like a Cobot, for instance, you can basically take the gripper out of the box, you can install it yourself within half an hour, and that's it, you're done. Nothing more to it. The second thing I think, which is very important, is again, if you talk sort of the most standard pneumatic grippers out there in the market are just open close. You can't control them in any way. It's full open, full close, or it's whatever force that you buy it for, right? Whereas OnRobot grippers, you can set the stroke and you can set the force, among others. So you can have one gripper, use it to pick up multiple items in different shapes, different size, different weight. So again, you get a very high flexibility in how you can use it. And I think especially for SMEs, which as I said is often high mix, low volume. And also they are dealing with many different products in many different shapes and sizes, and the same with machine tending especially, right? So you can have, as I said, one gripper and you can just adapt the shape and the stroke and the force, and also you can change the fingertips very easily to adapt to many different products. So I think the investment ultimately is much less than working with pneumatic grippers, even though they are at a first sight tend to be cheaper. So I hope that kind of answered the question.
Okay, thank you very much. So we have a couple of other questions coming in. So let me broadcast this question to the chat. So the next question is for Pilz. So Mark, can you help to introduce any software in the market for robotic application safety assessment? Are this software free?
I have not heard any software to help on robotic risk assessment. The reason is because the robotic application really, it's a very big topic. There are so many different kind of robot applications. Just think about welding, right? Painting and pick and place, even pick and place, many different kind of industries. So actually, it's not very, let's say, practical to have a software to help you to do that. And the ISO TS299, I think TS299, this safety work group used to have a topic to have kind of guideline robotic risk assessment, but I think this task group was already dropped, I think. And in Singapore, there the SMF, Singapore Manufacturing Federation, is also having a work group working on some guidelines for robotic risk assessment. And I happen to be the convener of this work group. So we are still working on that. Hopefully that in few months or maybe this year, we can provide the industry some guideline. But I have not heard any software for that.
Okay, thank you very much. So the next question is also for Mark. So apart from risk assessment, would Pilz assist to get CE certification for a piece of customized equipment?
Yes, we do. As I mentioned, on the service part of the business, we provide the safety service and also the compliance, the certification, right? So CE marking is one of our business. And as for CE marking, if your company has office or have the subsidiary in Europe, then you yourself can be the representative, and we help you to go through all this process. But if you are a local company, you do not have any office in Europe, then you need a local representative in Europe to represent you in the CE marking. And in this case, we can also provide this service. Our Pilz Europe, we are able to be your representative for that purpose. So in short, yes, we provide CE marking for the industries here.
Thank you very much. So the next question that we have, let me just broadcast this to the room. Okay, this question is directed at OnRobot. So I'll need Niels to help with this question. If robots are to be deployed in highly infectious environment, which requires it to be disinfected, how resilient is the robot materials today to resist the corrosive disinfectants?
I mean, I think I cannot speak for the industry as such. I mean, there's a difference between robot arms and robot end effectors, but generally, so our end effectors in general are either IP54 or IP67, which basically means it cannot take corrosive, what do you call it, like sodium hypochlorite and so on. It will not be able to take it. And I believe, I mean, maybe X, you can correct me if I'm wrong, but I also believe most of the cobots from UI is IP54, so that for sure will not be able to take these things as well. So from our side, and as far as I know, I'm not saying there's no products out there, but I think having highly or having these kind of material depends a bit how strong it is, but it has to, for us, live up to either IP54 or IP67 to be able to be used. That's sort of the best I can answer on that.
I agree with you, Niels. So if let's say it's a highly corrosive or infectious environment, right? Our robots are actually made up of PP as well as aluminium. So I did mention about UR Plus solutions, right? So you can actually use a protective sleeve actually to protect the robotics arm, and then you just have to design an end effectors or use end effectors that's able to use in that kind of environment.
Well, you can get gloves also for grippers and so on, but typically it's for maybe for waterproof and so on. But there might be stronger material out there as well, or there's companies that tailor make gloves actually for grippers as well. So there's different options out there if it's required.
Okay, thank you very much for the answers. Is there any other questions that you would like to ask? If there is any other questions, please enter them into the chat window. If not, I believe then that would be the last question from the group. So, yep, just waiting for a couple of seconds to see if anyone has any questions. Okay. Let me just scroll through. Okay, I think that's about it. There is no more questions. So thank you very much for attending our webinar. So we have come to the end of our webinar, and you will be receiving an email from us with a recording of this webinar. Oh, sorry, there's one question that just came in. So that will be the last question for today. Okay, how can we test your products? Let me just push the question out to the room. Okay, this last question is targeted at for OnRobot. So how can we test your products if we are looking at conducting a POC for a collaborative application?
Yeah, so proof of concept. Good question. So basically, Servo Dynamics is one of our preferred partners in the region, and of course in Singapore. So you can basically talk to them. So they are selling the robots, they are selling the OnRobot end effectors as well. So if you have a specific proof of concept you wanna try out and make sure that the products work as intended, you can talk to them and we can arrange for proof of concept. So that is pretty simple. So just talk to the team at Servo Dynamics.
Okay, thank you very much. That was the last question for today. So thank you very much for taking your precious time out to join us today. And thank you very much to our three speakers for sharing with us your knowledge. And we really appreciate it. So like I've said before, you'll be receiving an email from us together with a recording of this webinar. So thank you very much for attendance and goodbye.
Thank you.
Bye.
Thank you.
Thank you.
Bye.
Bye.
Bye.